This one, let's move to the second one now. 2.2.2. Here we simply have an algebraic expression which is very, very simple. It has 23 minus 27, then plus x minus x plus 7y minus y. Now we come across a beautiful factor there which is simply called the additive inverse. Now we simply call additive inverse. So this one is just this one, we consider it as additive inverse. Whenever we have plus x minus x, they're just gonna give us 0. It's the same as 2 minus 2. Remember, this is plus 2 minus 2, it's just gonna be 0. So if we're gonna add or minus both of them, then they give us 0. We consider them as additive inverse. So now this is the problem we have here for now. So we have 23 minus 27, in which now we're gonna have 23 here minus 27, and then plus x minus x, we get 0. So these two, we're just gonna cancel them out. Then we are left with plus 7y minus y here. Now, looking at the fact that we have 23 minus 27, we know very well that if we have 23 minus 27, we're simply gonna have negative 4. And then we have 7y minus y. Know very well that now here there's an invisible one. So if we have 7y minus y, the variables are the same. We simply subtract the coefficients, which is going to be 7 minus 1, it's going to be 6. And then we have plus 6y here. Then we are just done. It was supposed to be 1 mark, it's fine. So this one was straightforward question, 1 mark for free. So let's move to the last one on 2.2. So we have this one which looks a bit challenging, but it's also something that is playing around your brain. So now let's look at this one. It's a cube root of 27 minus 8 all raised to the exponent of 3. Now this one we just need to punch it in the calculator, but let me show you how we break it down. So in order for us to break this down, we'll put the brackets. Remember, within the cube root we have 27, and 27 we can change it to exponent of 3. And then outside we have 3 here, then it's minus 8 raised to an exponent of 3. We can even change this one to 3, but it's fine for now. So let's look at this one here. It's simply going to be 3. We take this 3 inside, we divide by the 3 outside, then minus 8 raised to an exponent of 3. Then this is just going to be 3 divided by 3, which is going to be 3 to the exponent of 1 minus 8, then raised to an exponent of 3. And then obviously we know now that 3 minus 8 is simply going to be negative 5. And then we have negative 5 raised to an exponent of 3. Then here we simply multiply these times 3. So it's going to be negative 5 multiplied by negative 5. Then negative 5 times negative 5, we get positive 25 multiplied by negative 5. Then 25 multiplied by negative 5 is simply 125. So we're just going to be having negative 125. Then that is when now we are done. And the marks there, it was just 2 marks. So it was playing around, there were no variables, but yeah, all in all, it's very, very simple. So let's move now to the next one. Hope everyone is still following for now. And then let's move to 2.3. We're simplifying now. It's just exponents. So we have 2 brackets. We have negative 3x squared, then followed by 3x all raised to the exponent of negative 2. Now let's check. So we have this one. Remember, we're just going to go back to the laws of exponents. If we have a b raised to the exponent of 2, we simply distribute these 2 to both variables that are multiplying each other. So we're going to have a squared, b squared. That's just the basic of the law. Then now let's look at this one. Just put it there as it is. It's just a square. Then here we're just gonna do this. We distribute this negative 2 to both. So if we distribute negative 2 to 3, we're just gonna have 3 to the exponent of negative 2, then x to the exponent of negative 2. And then obviously from there we just put it as it is there. Now we look at this one, which is negative 3x squared multiplied by 3 to the exponent of negative 2, x to the exponent of negative 2. Now here we have the coefficient, as well as this is a coefficient, but let's change this first. Minus 3x squared this one is supposed to be 1 over, remember 3 squared, it's just gonna be like this, 3 squared, but we're just gonna change it to 1 over 9. Then we have x to the exponent of negative 2. Now look, so going forward, we have negative 3 multiplied by 9, by 1 over 9. So we're gonna have negative 3 over 9. Then remember, going back again to the laws of exponents, they simply say if we have a to the exponent of 1 multiplied by a to the exponent of 2, we must remember the law that says the powers of the same bases, when we are multiplying them, we simply add the exponents. So we're gonna have a into raised to the exponent of 1 plus 2. Then we simply have a to the exponent of 3. Then now let's simply look at this one. Negative 3 divided by 9. Then we have x. Remember, we need to add these two as it was there. So 2 plus minus 2. So now let's look again. Negative 3 now divided by 9. Negative 3 goes into 3 once. Then it goes into 9 3 times. Then it's just going to be 1 over 3. Then x to the exponent of 2 minus 2. 2 minus 2 is simply negative 1 over 3 x to the exponent of 0. Then anything raised to an exponent of 0, it's always 1. So the answer is just going to be negative 1 over 3 into 1. Then our answer is negative 1 over 3. Then we are done with that one. It was long there, but 2 marks there, at least 3 marks or 4 for a grade 8 and grade 9 learner. But now let's move to this one. It's still fine. We're just gonna remove this. Then we move to these two. Now this one, it's a bit of a nice problem. So let's look at it. It's just also considered as an exponential problem. So now let's look at 4 to the exponent of n. Now there's something we call prime factors. So if you look at the base of 2 as well as this base of 2 and 4, there's something common, which is a prime factor of 2. Now looking at 2 to the exponent of n multiplied by 2 to the exponent of n plus 1, there is a law that we can implement here, which is the powers of the same bases, the product of them, we should add the exponents. But for now, we're just going to leave it there. We have 4 here. 4 is, we can change 4 to an exponent of 2. Then we have n outside. Then we bring this back again. 2 to the exponent of n multiplied by 2 to the exponent of n plus 1 all over 2. Then we have 2 multiplied by n here. It's also part of the exponential laws. Then we're going to have 2n here. Now, we should know this law again. So there's this law now. If we have a to the exponent of 1 over a to the exponent of 2, we need to simply subtract the exponent. So we're just going to subtract 1 and 2, then we get a to the exponent of negative 1. Now let's look at this one. We do the very same thing since the bases are the same. Remember, at the top, if we are multiplying, we simply add the exponents. So we're going to have 2 to the exponent of n plus 1. Then we only subtract this one based on the division law, which is minus 2n. Now if you can look at it, n plus n is supposed to be 2n, then minus this 2n here. We are going back again to additive inverse. So we have 2 to the exponent of 2n minus 2n, it's going to be 0. Then 2 raised to an exponent of 0, it's just going to be 1. So we are done with that one. It was just 2 marks, but for a grade 8 learner, I'm still saying these marks allocated here were a bit not fair for them, but it's fine at the end of the day. Moving forward, we have this one. It's just 1 mark. It has just one thing to do. We have 12 multiplied by 7 to the exponent of 0. We know very well that anything raised to an exponent of 0, it's always equals to 1. So we have 12 multiplied by 7 to the exponent of 0, it's supposed to be 1. Then 12 times 1, it's 12. Then this was just 1 mark. So yeah, guys, I hope you did understand. If you did not understand somewhere, you just need to just throw a comment there, and then I'm just gonna follow it and try by all means to fix whatever that we had to fix there. And at the same time, thank you so much, guys. See you on my next video.